All right, so Chapter 8, Lesson 4 is multiple representations of functions. In the warm-up, it says a group of friends are going to the museum. Each friend must pay an admission price of $9. Okay? Number 1 says complete the table and graph the ordered pairs, number of friends, comma, total cost. So that's your X and that's your Y. So here you can see in the words there that it says each friend must pay an admission price of $9. So here, if we have one person going, that's $9. If we have two people, that's $18. If we have three, $27. And if we have four, $36. So this is what your table looks like. So now we're going to graph. Okay, so the ordered pairs are 1, 9, 2, 18, 3, 27, and
4, 36.
Very good. So this is what your graph looks like. So number 2 says describe the graph. Okay, so looking at this graph, we have number of friends here, total cost here, and these are our ordered pairs that are graphed. What does it look like to you? A straight line. Very good. So here, that the ordered pairs lie on a straight line. Now, let me ask you this. Should I connect the dots? Should I draw the line? Now, down here for the X value, it's number of friends. And then up here for the Y value is total cost. Now, think about this. In here, if I drew this line, I'm just gonna go ahead and draw the line. If I drew the line, that tells me that I could, bless you, go here and here. That means I can go here and here. Is everybody with me? Now, think about what your X value represents. Number of friends. So this is 1/2, 450. So can half a friend of ours go to the museum? No, you can't have half a friend go to the museum and then just pay for $4.50 of them, right? No, you can't. So, in this case, we do not draw the line. So now, number 3 says, write an equation to find the cost of this should say X tickets. Find the cost of X tickets, okay? So here, looking at our function table, we're going to look to see how do I go from, how does our Y value change? So 9 to 18, 18 to 27, and 27 to 36, what do? We're going to add 9 each time, right? So we add 9 each time. Now, what do I do with that 9? What do I do with the 9?
Put it as the X.
That is, we're going to multiply it times the X. Does everybody see that? So the equation will be 9 times X, and that's going to give us our total cost, which is Y. So our equation is Y is equal to 9X, where Y represents the total cost and the X represents the number of friends. All right, number 4 says list the ordered pair for the cost when 5 friends go to the museum, and we want to describe the location. So here, how do I figure out how much it's going to cost for 5 friends using the information that we have here? So, yes, we are going to put 5 in for the X. Very good. So, we have Y is equal to 9 times 5. So, Y is equal to 45 when X is equal to 5. So that means that the ordered pair is going to be what comma what? So your ordered pair is going to be 5 comma 45. 5 comma 45. And when we describe the location here on the graph, we're just going to go to the right 5 and up to 45 right there. So now we're going to represent functions using words and equations. Make sure you write down your heading. Represent functions using words and equations. Okay, so here in words it says a runner's distance in a marathon is equal to 8 miles per hour times the number of hours. Okay, if you look here, this is the equation. D is equal to 8 times T. It matches up. The words in the equation match up. Here we've got the runner's distance, that's D, in a marathon is equal to 8 miles, 8 miles times the number of hours. Everybody see that? Words and equations can be used to describe functions. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, we want to determine what variables to use to represent different quantities. Now, when we do that, you guys, we want to, when we determine the variables to use, we would like to use variables that make sense. So, for example, D for distance, T for hours, M for miles. Is everybody clear with that? Okay. You want to use variables that make sense. Okay. So let's take a look at example 1. Example 1 says, the drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total amount earned, T, for selling P pies. Okay. So the first thing we want to do here is define our variables. Okay, so we've got T for the total amount, T for the total amount earned, and then we've got P for the number of pies they sold. Okay, now if we go back to our word problem, it says they are charging $5 for each pie that they sell. So, in this yellow highlighted part, $5 for each pie they sell, what word tells me the operation? Very good. Each tells me we're going to multiply, right? So here, we're going to multiply $5 times each pie, there's times pie, and then that's going to be equal to the total amount that they earned. And there's my equation. Example 2 says, in a science report, Maya finds the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths B, a non-active person, takes in M minutes. Okay, so here we're going to, again, define our variables. So let's see. The total breaths, B, that's total breaths. M is going to be our minutes. And now we can go back to see what tells us what we're going to do. So here, 14 times each minute. What word tells me the operation? Each. Again, it's each. So here we have 14 times the number of minutes. So 14 times M gives me the total number of breaths. So, for got it, letter A, a mouse can travel 8 miles per hour. Write an equation to find the total distance, D, a mouse can travel in H hours. So here, we want to find the total distance, D, bless you, a mouse can travel in H hours. So those are my two variables. Okay, now I'm going to go back to the words and see what phrase will help me figure out what I need to do here. So here it says a mouse can travel 8 miles per hour. What word tells me the operation there? Per. Very good. Per tells me again I need to multiply. So we're going to multiply 18 times the number of hours. So that's going to be 8, not 18. 8 miles per hour. So that's going to be 8 times h, and that's going to be equal to the total distance, which is d. All right, problem B says Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies, C, that she can make in each hours. So why don't you do letter B on your own, and then I'll show you your solution. So here we've got 36 cookies each hour. C is equal to cookies. H is equal to hours. So 36 times the number of hours, 36 times H, equals the total number of cookies. So now we're going to represent functions using tables and graphs. Okay? So we've seen a function as an equation. We've seen the function using words. We've actually seen a function using tables and graphs yesterday, right? So here, table and graph. Okay? And these are ways that you can observe a function. Okay? All right. All right, so example 3 says a student council is holding a car wash to raise money. They are charging $7 for each car they wash. We want to write an equation and make a function table to show the relationship between the number of cars washed, C, and the total amount earned, T. So, once again, we're going to look at what our variables are. Okay? So, let's see. The total amount earned is T. That's our total. And C is the number of cars washed. Now, going back to this problem, it says up here that they are charging $7 for each car they wash. Okay? What word tells us the operation there? Each. Again, that tells us we're going to multiply. Very good. So we're going to multiply 7 times the number of cars. You see that? So there is 7 times C, 7 times the number of cars, and that's going to be equal to the total amount earned. So there is our equation. Is everybody clear? The function rule, now we're going to take this and we're going to put it in our function table. The function rule is 7 times C, 7C. And now we're going to choose numbers to put into our function rule. So we can pick 0, 1, 2, 3, 4, or whatever you want, right? So then you're going to simplify. After you substitute, you're going to simplify to get the total amount earned. So here, once we do that, this is our function table. This is our function in the form of a table. Now, what are the ordered pairs that we will graph? 1, 7, 2, 14, 3, 21. Very good. So now we graph. And when we graph, we put them on the coordinate grid, and this is what our graph looks like. They look like a straight line, so this is a linear equation or a linear function. Now let me ask you this. Do I draw the line? So you can have half a car, but when you take it to this car wash, you can't say, wash half of my car and I'll pay you half. Is everybody clear? So it's either you wash the car or you don't wash the car. You got it? So there, in this case, we do not draw the line. So, for the last got it, here it says, while in normal flight, a bald eagle flies an average speed of 30 miles per hour. We want to write an equation and make a function table to show the relationship between the total distance d that a bald eagle can travel in 8 hours. Once we do that, then we want to put graph our ordered pairs. So, first, let's see what our variables are. We will define our variables. So, the total distance that a bald eagle can travel, that's the d, that's our total distance, in h hours. Okay? So now we're going to go back to the word problem and look for what phrase tells us what to do. What's that phrase? So here we have 30 miles per hour. That tells us what to do. Okay? And yes, just like you said, per means we're going to multiply. So we're going to multiply the miles times the hours to get the total. You got that? So here, that's our equation. When we write our equation, we have miles, so that's 30 miles, times the number of hours, and that's going to be equal to our total distance. Very good. D for distance. Okay. So now we're going to write our equation or our function in a function table. So what should I choose for hours? 1, 2, 3. We could choose 0, 1, 2, 3. We can start with 1, 2, and 3. Okay, 1, 2, and 3. Okay, because we know if he flies 0 hours, he's going to go 0 miles, right? Okay, so here we've got h is equal to 1. So 30 times 1 is 30. And h is equal to 2. So 30 times 2 is 60. And h is equal to 3. So 30 times 3 is 90. Very good. So our ordered pairs are 1, 30, 2, 60, and 3, 90. Very good. So now we graph. So 1, 30. So this is what our graph looks like. And yes, it is, the points lie in a straight line. So this is a linear function. Very good. Now let me ask you this. Do I draw the line? So yes, we are going to draw the line, because when we draw the line, and I'm going to put the 0 on there too, okay? When we draw the line, you can see that I can go, the eagle can fly half an hour, right, 30 minutes, and end up on the line, right? The eagle can fly an hour and a half and end up on the line. Is everybody with me?
Yes.
So in that case, you do draw the line.